Hello, welcome to Technoveda Solutions. In this video, we will discuss about generating a duty cycle for an LED which is connected to pin number 6 of port C. So now, as usual, we include the header file std.h to declare the unsigned int variables. So we are using three functions in this. One is GPI initialization, another one to define the LED bit, and another one for the delay. So here, as I said, we will be using GPIOC. So first we have to enable the bus register. So we have defined bus register and two register related to port C, that is motor and outer registers. So outer register will be used to define the output value, and motor is defined to used to define the input or output configurations for the port. Then here one global variable is declared, which is named as a duty cycle. So here we will be giving the percentage of duty cycle. Depending on what percent we give, accordingly the LED glow duration will change. In the main, first we call the GPIO initialization function. So if we go to that function, we can see here that we are enabling the port C, that is the third pin of AHB register, and then we are defining port C, that pin number 6 of port C as an output pin. For that, pin number 12 and 13 are configured as 0, 1. So that will define the pin number 6 of port C as an output. Then in the out register, we set the pin number 6 as the output register. In the we will may set it to 1 to define this as an output. Then coming back to main function, so inside the while one, that is an infinite loop, all we are doing is just toggling the uh, pin number 6, that is the LED connected to pin number 6, and the LED can be connected to any GPIO, and accordingly we have to modify the program for that particular pin numbers, whichever the pin we want to connect the LED to. So here we are setting the pin number 6 to 0, so it is the active low, so it will be glowing now. Then we are defining a duty cycle here. Whatever duty cycle we have given, that duty cycle period we are passing to a function delay. Again, here a delay function does not give you any exact delay, it is just a normal function. So only we make sure that the delay of on period and the delay of off period will totally make it 100%. So if we are passing a duty cycle as a variable here, then after we switch off the LED, then we will be passing 100 minus duty cycle as a variable, so that the effective period of on and off together will be 100%. So as we change the variable value here, accordingly the duty cycle of the LED will change. In the delay, as usual, we just use a nested for loop to generate a particular delay, and then we call that delay in the main function. So this is a simple program. The as usual, we will be simulating this on the Proteus. So for that, we need to generate a hex file. So we have to go to properties and enable the hex file generation. Now let's build the project. So if we click on the build, you can see that 0 error 0 warning, the project has been built, and we have a file name being generated. We can also see the various segments here. So text segment, data segment, BSS segment, and hex code length. So we can see all the segments and intermediate files also generated here. Anyway, they are all technical details. Now we will go to simulation on the Proteus. So here in the Proteus, just double click on the microcontroller and make sure that the microcontroller what we have selected is same as what you have selected for the project creation, that is STM32F4x So they both the microcontroller should match, only then the program will be executed properly. So if we double click and if we browse the hex file and then click OK, so hex file gets loaded. So also we should make sure that hex file is created in the STM cube when we are compiling the project. Now if I run the code, we can see here the LED is glowing and it is switching off after particular duration. So now as we have given a 50% duty cycle, so on and off period both are same. Now I'll just stop here, and if we go to STM cube and if we change the duty cycle, say I make it 90% and just build the project again. Once we build the project again we'll go to Proteus and reload the hex file once again. And once we reload the hex file and then if we run the program, now we can see that it is on for a very long period and off is very small because we have given 90% duty cycle. So 90% of the time it will be on and only 10% of the time it is off. Similarly, if I change the duty cycle to 10% and build the project and again go to Proteus, reload the hex file. Every time we make any modification we have to rebuild the project and we have to reload the hex file. Only then that whatever the changes we have made, that will be effective. Now if I run, you can see that it is on for only 10% and 90% of the time it is in the off state. So like that, depending on how much percentage we want to keep it on or off, based on that we will be able to set the duty cycle by changing the percentage here. So that's it in this video. So you can like the my video, share, and if any comment are there, please add the comment. And if you have any doubt or any clarification, you can always mail to technoveda79@gmail.com. And if any query is that, either you can send the mail or you can put the comment. Thank you.